What we're doing today, you guys, is we're going to start looking at how to solve systems. And systems are two or more equations, and they have more than one variable. So all the stuff that we've been doing so far kind of looks something like this, where we have like x plus 4 equals 7, and so there's only one variable, just this x right here. But now what we're going to be doing this time is we're going to be solving things that look like this. If you look at this number 1 example, where see how there's two variables now and there's two equations, so there's an x and there's a y, so we call that a system of equations. There's three methods of solving by a system of equations. The first is the graphing method, then there's a substitution method, and then there's also a method called elimination. So what we're going to do is we're going to start with the graphing method, since that's what you guys have been doing lately, and so you're going to need to know how to graph. If you can graph in slope intercept, that's even better because it will be easier. So what I've done here is I've split this into two boxes, and you want to start here on the how to solve box. That's the first place you want to start. And so I think for the most part for today, they only give you two equations, but basically to start every problem off, you're going to need to put each line in slope intercept form. So if you forgot what that is, it's y equals mx plus b. Okay, then you're going to take the first line after you put in slope intercept, and you're going to graph using the y-intercept, or the b, and the slope. Remember the rise over 1, we're going up or down 1 and then to the right. Once you've graphed that line, you're going to go to number 3. You're going to go to the second equation and do the same thing, but you're going to graph it on the same axis. So you're not going to start a new graph. You're just going to plot it right on the same coordinate plane that you have the first line on, because the point of it is that in step 4 you want to see where the two lines intersect, if they even do intersect. Okay, and so once you've plotted both of the lines, there's you want to go to the second half and analyze what you got here. So the ideal thing is that hopefully they intersect, which means that they cross each other. And so if they intersect, there is one solution to the problem, and that one solution is wherever the lines cross. So if you have something that looks like this, you drew one line and it looked like that, you drew another line and it looked like that, their point of intersection is right here where they crossed, and that would be the answer for what their solution would be. Okay, if you put the lines in slope intercept form and you notice that the slopes are the same, so maybe you put them in slope intercept form and you get this. And you notice that the slopes are the same. See how the m's are both the same? What we say is that the lines are parallel, and there's no solution. There's no solution because if they're parallel, remember, that means that they look like this, and so they look like train tracks. And so they're never going to cross, which means if they never cross, you'll never have a solution. So if you graph it and the lines end up looking like the train tracks, or they're parallel, there's no solution. Or if you just put it in slope intercept and you notice that the m's are exactly the same, then there's no solution to there too. Okay. The third situation is maybe you start working on your slope intercept form, and as you're moving things around in the equation, you end up with this. The first line looks like this, and then the second line ends up looking like this. The two lines are exactly the same. What we call that in our graphing method is we say that they coincide, okay? And it just basically tells us that the two lines are exactly the same. So again, it's a special situation because they're never going to cross, so there's never going to be a point of intersection, which means there's no solution to it. But the special case is when the lines look exactly the same, we say that it has infinite solutions, okay? So in the difference between 2 and 3 is in 2, the slopes are the same, but the b is different. In number 3, the line from the front to the back of it is exactly the same. They're identical. Okay, so that's the two differences for what situation 2 and situation 3 is. So let's go ahead and practice with these. So looking at our example number 1 right here, we have two lines, two equations, 2x plus y equals 2, x minus y equals 4. My suggestion is don't get overwhelmed by looking at both of them. Let's call this first equation A. Let's first call this second equation B, okay? So let's just work on A and putting it in slope-intercept form. So remember, slope-intercept form means, you guys, that we're getting y by itself. So we're going to move everything out of the way around y. So the only thing that's in the way is this 2x here. So to get rid of it, we subtract it on the other side. Okay, these guys cancel, so I'm left with a positive y equals 2 minus 2x, but remember slope-intercept form tells us that we want the x thing first, so let's have these guys switch places. So instead of y equals 2 minus 2x, let's call this y equals negative 2x plus 2. So they just switch places because in slope-intercept form we want to have the x thing first before the y-intercept, okay? So here's equation A, so I'm going to just circle this so that we know we have it, okay? Now let's work on equation B. So equation B looks like this. X minus y equals 4. So same idea here. We need to get the y by itself. Okay, so we have that negative in front of the y2 that we don't like, but let's get rid of the x first. So we subtract it on both sides. Okay, the x's cancel, so I'm left with negative y equals, let's switch this, remember we want the x first, equals negative x plus 4. Okay, I don't like having this negative y here because what I want for slope-intercept, if you follow my cursor right here, I want a positive y. So if we want to get rid of that negative y, all we have to do is multiply a negative 1 on both sides so that we can get that y to be positive. Okay, so when we do that, on the left side, negative 1 times negative y will make the y positive. And then we distribute this negative 1 there and there. So it changes all the signs, so we get x minus 4. So here is my second equation here, okay? So I have my two equations now, and all I need to do now is graph. So hopefully you guys remember how to do that and graph. So let's start that here. So here is my 0, 0 right here. Here's my 0, 0 right here. I'm just going to put a little circle right there so that you know, okay? And let's change the color on this so you could see. So looking at equation A, I look at my B, it's right there. So my starting point is going to be 0, 2. Okay, my slope is negative 2, so let's put it over 1 so that we know how to graph that out there with a denominator in there. And so here we go. So for equation A, I'm starting at 0, 2, which is here's 0, so I go up 2. So I'm going to put a dot there. Okay, you put a dot there, and then using the slope, what that tells me is I am going to go down 2. So I'm going 1, 2, and then to the right 1. So there's my dot right there. One more time, down 2, and then to the right 1. And then all I'm going to do is I'm just going to connect the dots now. Oops, that did not work out. I apologize for my horrible line drawing here. So there's that, and there's that. Okay, so there's equation A. Now let's graph equation B. So B, I'm here at negative 4, which tells me I'm going to start at 0, negative 4. I have no number in front of this x written, so remember when that happens, it's a 1, and if I want to make it a fraction, I just make it 1 over 1. Okay, so here we go on the graph, starting from, let's plot our y-intercept first. So here's my origin, or my starting place. So I go 0, negative 4 would be 1, 2, 3, 4, and I put a dot right there. Okay, then using this dot, I'm going to work on the slope. So I'm going up 1, over 1. One more time, up 1, over 1. Okay, and then I connect the dots for line B. Okay, and so they intersect, which means there's going to be an answer. All you do now is you look at where they intersect. So starting from my origin right here, the starting point, let's figure out where they intersect. So if I go towards the intersection point, I go to the right 1, 2. So in my x-axis is going to be positive 2. And then I go down, um, 1, 2. Okay, and they intersect about right here. So I went to the right 2 and then down 2. So my intersection point for this has to be 2, negative 2, okay, because I went to the right 2, which would make it positive, and then I went down 2, which is negative, and all you do is this is your final answer, okay? So that's an example of one where the two lines after you graph them, they have an intersection, and you go and you look at it and see where they cross, and whatever that is, that's your answer for this, okay? Because basically what will happen is this is my x, remember? That's my y. And so if you plug them into either of the equations, they should end up working out. Okay? And that's your answer for x and y for these two equations. Kind of cool, right? So let's go ahead and look at another example here. And here we go, okay? So again, so that you don't get too overwhelmed, let's call the first equation A. Let's call the second one B. Okay? So let's work on A first and put it in slope-intercept form. Okay? So to put this in slope-intercept form, remember you want to get y by itself, so you don't care about that negative 3 in front of it. You're going to have to get rid of that later on too. But you keep them together till the end because they're glued together right now. So let's move the x over first. And then these guys cancel out, so I have negative 3y equals, let's rearrange this so the x is first, negative x plus 2. Okay? I don't want to have this negative 3 in front of the y, so to get rid of it, remember we divide. Okay, these guys cancel, so what am I left with? I'm left with x over 3 minus 2/3. This guy's a little weird, you guys, when you're graphing this x over 3 business. X over 3, when you have the x on the top with no number in front or that 1 in the front, you can also rewrite it to look like this, which might help you when you graph this out. Okay, so x over 3 and 1 over 3x is the same thing, so it's just your preference. I think that the boxed one is easier to graph, so if you end up with an x over 3, just put a 1 in front of the x, and then you can turn it into something that looks like that. Okay, let's work on equation B here. So 3y minus 1 equals x. So I need to get y by itself again. Remember, you want to get rid of that 3, but you're going to get rid of it last since it's glued to the y. And so what you're going to do is you're going to add 1 to both sides. Okay, so those cancel. You end up with 3y equals x plus 1. I want to get rid of this 3 because it's the last thing that's there. Okay, these guys cancel. And remember, this thing is weird right here with the x over 3, so rewrite it so that it looks like this. Y equals 1 over 3x plus 1/3. The next step for this would be to graph this, but look at what happened here, you guys. If you look at the two equations, what do you notice? The slopes are exactly the same, okay? So you actually don't even have to go to the graph at this point, because what happened when the slopes were the same? Let's scroll up here. So if you have the same slopes but the different y-intercepts, so see how the b's are different? This one is a negative 2/3, this one's a positive 1/3. So the slopes are the same but the end parts are different. Then we say that what happens? We see that there's a no solution situation there, okay? So it's no solution. We don't even have to graph it because we see that right away after doing the algebra. So all we have to write here is that there's no solution. Okay, so if you wanted to graph that out, that's fine. You could graph it out, and what's going to happen is that it's going to look like a train tracks pretty much, okay, where they're going to be parallel lines that never cross. So if you forget about that trick and you just graph it and you realize they're never going to cross anywhere, that's because there's no solution. Okay, so if you can remember, you can save some time though. Just look at the slopes and make sure that they're see if they're the same. If they're the same, check the b's. If the b's are the same, then it's going to coincide. If they're not, then it's a no solution situation. So if we scroll up to this first example, see how the first slope was -2, the second one was 1. Unfortunately, when they're different, we're going to have to continue graphing it out. Okay, so that's an example of one that would look like a no solution. Let's go ahead and go on to our third example, you guys. Here's my equation A. Here's my equation B. And let me switch the color out here, actually. Okay. So let's put A into slope-intercept form. So if you put it into slope-intercept form, you want to get that y by itself, so I'm going to box it so I remember. Okay, so let's move that 2x over. Okay, which means that these two x's are going to cancel out. I'm left with negative y equals, remember I'm going to switch it so it could be in the correct slope-intercept form. Negative y equals -2x plus 1. I hate that we have a negative y, so remember to get rid of that negative y. We're going to multiply everything through by -1. So it's going to go here and there. Okay, so we have -1 times -y will make it positive, and then the -1 on the right side of the equal sign is just going to change all the signs. So here is my first equation. Okay, let's work on equation B. So I have 6x minus 3y equals 3. I want to get the y by itself, so let me box it so I remember. And so first thing to get rid of is the thing with x. So we subtract 6x from both sides, cancel, and then let's rearrange it so that the x term is first. Okay, now we're going to divide everything through by -3. Divide, divide, divide. Okay, so this cancels and we're left with y equals 2x minus 1. There's my second one. Now let's look at the slopes before we move on to graph it, because we may be able to save some time. So first equation, the slope is 2x is 2. Second one is 2 as well. Let's go to the back numbers, and they're both -1, so both the lines are exactly the same. Okay, so remember, when they're exactly the same, if we scroll up, what does that mean? When the lines are identical, or they coincide, that means that this one's going to have infinite solutions. Okay, so there's going to be no need to graph. If you want to, you can, but you're going to end up with one line, just one line when you graph it, because it's the exact same line. So instead of, when it's an infinite solution, you're not going to have two separate lines, you're just going to have one, because since they're the exact same equation, when you graph them, it's going to be just one line. Okay, if you want to save some time and you realize after doing all the algebra that the equations are exactly the same, we just say that there's an infinite amount of solutions. Okay, and so those are the three different situations. What I want to do is I want to give you guys one last one, which is number 4. And this one is not a no solution or an infinite solution. It's one where you actually have to graph, so that you guys can get practice with that one more time. So here is number 4A, 4B. If we look at A, it actually is already in slope-intercept form. It's a little weird because it doesn't have the, the back number. If it helps you out, which I think it does in my experience, when there's no back number, what might help you out is if you call this, just put a +0 at the end as a filler, so that you know, and then that also gives you a definite starting place on where to begin. Okay, so A, there was no work needed except to just put a +0 at the end so that we could put it into a correct slope-intercept form. For B, if you look at B, B is also already in slope-intercept form, so I did all the work for you. But the question is, how do you graph a fraction? So for A, this one's pretty okay. The starting place is 0, 0, because the B is 0. And then remember, the slope is going to be 1 over 1. Now for the equation B, this is a little weird. How do you graph a fraction? What you want to do is you want to turn it into a mixed number. So 1 2/3 would make that a mixed number. Okay, that's your starting place. And then here's your slope, which is straightforward on what to do. So let's go ahead and start graphing this here. Let's expand this out here. So there is my starting point, that little dot in the middle, just so that you know. So starting with equation A, my starting place is 0, 0, easy enough, so I'm going to bubble that in. And then my slope is 1 over 1, so I'm going to go up 1 over 1, put a dot, one more time up 1 over 1, put a dot, and then we just connect all of the lines together, or all the dots together. You got to make these lines extra long, you guys, because otherwise it's going to be hard to find the point of intersection. Okay, so the first line was easy to graph. Now let's go to the second one because it's a fraction. So we're here at 1 2/3. Basically, when you have a fraction, you just estimate. So 0, 1 2/3 would be 0, and then we're going to go up 1, and then 2/3 would probably be right about here where I'm putting my dot here, really close to the 2, but not quite. Okay, so it's there. And then now from this dot, all you're doing is you're going to go down 2, so we're going 1, 2, and then over 3, 1, 2, 3, so about right there. Okay, same thing one more time, down 2, 1, 2, and then over 3, 1, 2, 3. Okay, remember when you're doing the fractions and you're doing the up 2 over 3, all that business, you have to preserve that it's kind of a guesstimated line there. That was a horrible line to connect the dots. Okay, so they're not going to be actually on the little corners. They're going to be a little skewed because since they're fractions and you estimated, you want to preserve that as you're drawing the dots. Okay, that's the best straight line I could get here. But the good thing is that it's obvious where the point of intersection is. So if you look at this, you guys, let's find the point of intersection, which is, here's my starting place, 0, 0, so I go to the right one and up 1. Okay, so if I'm going to the right one and up 1, that means that I have one solution. Okay, so my point of intersection, if we went to the right one, it's going to be a positive 1, and then up 1 is also a positive 1. There's my x, there's my y. So the final answer for this is 1, 1. Okay, so don't worry, we're going to also practice with this on the tomorrow. You gotta be good with your graphing. So there we go with that. And if you can graph, you're gonna be good. If you can remember the rules about the same slope or same lines, and you can remember that, you're gonna be good to go for this. Okay, so write down your questions. We'll also go through them in class tomorrow. So don't forget to take the quiz.